I want to talk a little bit about how I created the equations for the circles based off of this piece of artwork from 13 Animals, 13 Circles, which I was really inspired by. And I thought, okay, I wonder if I could recreate this piece of art in some of the graphing calculator tools that I've worked with. So because I wanted to start with circles, I decided to go ahead and use GeoGebra because GeoGebra is a really great resource for anything that you're doing that is really geometric because it has some built-in tools to create different shapes like circles already. So starting just at the basic calculator suite, the first thing that I did was I put the image in there. So if we go ahead, I've just placed my image somewhere on the screen. Where it is doesn't really matter. I'm going to go ahead and hide those points so I'm not moving it around anywhere. And now the bulk of this problem is really about how do I take sort of this arc that we already have going on, and how do I go from an arc to the actual equation of the circle? So I'm going to go ahead and open up another GeoGebra calculator to illustrate how I did this. If I want to make a circle that goes through both of these points, well, one way I could do that is I could figure out, okay, what is a point that's equal distance from both of these points already? So for example, I could put a point right here and make that the center of my circle. And so there we have a circle that goes through both of those points A and B, but that's not the only point that could be the center. For example, if I put a point right here, that point is also equal distance from A and B. So there we have another circle that goes through both of those points. And again, I could pick any other point that is equal distant from both of these 2 points, and I'll have another circle that goes through it. So what we get if we look at all of these points that are going right through the middle, we get a line. So as long as my center point is anywhere on this perpendicular bisector, is the name of the line there, then I'm able to create a circle between these 2 points. Once I have that perpendicular bisector, I need to know another point that I want on my circle. So I'll go ahead and say I want it to also go through this third point there through the origin. Now, if I consider, for example, point B, and this point I just placed at the origin, if I want those points to also be on my circle, then they also have to be equal distant to both of them. So I can do another perpendicular bisector between those two. And now I know the only point that is equal distant to all 3 of these is right here where those perpendicular bisectors intersect. So now, if I take that as my center point and go through any of my other points, they're all the same distance away. So now I have a circle that goes through all of the points that I want. And this was the general concept that I used to create my graph, or my equations for the circles that are on this image. So given that I just took a screenshot of this, I don't have this as a vector image, right? So I'm going to basically be as precise as I want to get by just zooming in. So it probably will be a little bit off compared to the original image. But so what I can do is I want to pick any of the circles that I want to create. So for example, let's say that I want to figure out the equation for this circle here on the rabbit's leg. What I'm going to need to do for that is put some points there. So it doesn't matter. Those points can be anywhere that I want, but I just need 3 of them. So there we go. I've got 3 points now, and I'm going to go ahead and hide the labels because I do not need them. So now that I've got those points, I can use the perpendicular bisector tool there we go. We've got a line of potential center points. And then I'm going to use the point that I haven't used yet. And I could do this point or this point. It doesn't matter, just needs to have any of them. And now that point where they intersect is going to be the center of my circle. And then if I use the circle tool, I can mark that as my center. And there we go. Now we have a circle that fits along that curve in our image. And what's really nice about using the calculator suite on GeoGebra is it also automatically gives me the equation of this circle. So if we go back to the original image that I had, you can see that I did get 13 circles, just like she claimed to have used, and we have those 13 circle equations, all of which came from creating points and doing perpendicular bisectors in order to figure out where their center was so that we can get their center and their radius. After creating the initial video, I wanted to come back and add to it a little bit because I did learn after the fact that Desmos does have a geometry calculator itself. So it has a lot of the tools that we saw in GeoGebra. It does have a little bit more limitations to its tools, but one thing that it does have, if we have 3 points here, if we click on this arc, you can create just an arc from 3 points. You can also create a segment between 2 points, and you can create a perpendicular line to that segment. But what it doesn't have specifically is a perpendicular bisector, so you'd have to figure out where the center of those 2 points are yourself when figuring out the perpendicular bisector if you want to get the full circle instead of just the arc so that you can figure out where the center of that circle is. So another cool graphing tool to explore.